Hello everyone, my name is Partho Das, Assistant Professor, Department of Electrical Engineering, JS College of Engineering, West Bengal, India. Welcome to my class. So as you can see, the today's topic is the hysteresis motor. So let us start. What is hysteresis motor? What are the working principle of hysteresis motor? Why it is named as hysteresis motor? So if basically we will start with the name. Why this it has a name of hysteresis motor? So the point is that as this motor works on the hysteresis loss principle, so that's why it has a name of hysteresis motor. So let us start with the presentation. Okay, so these are the contents for today. The definition, then the construction of the stator part, construction of the rotor part, operation or working, torque characteristics, mathematical analysis, that is the mathematical equation that we have in this case, then the application, advantages and disadvantages. Okay, so first by definition we will start the presentation. So what is hysteresis motor? And hysteresis motor is a synchronous motor with a uniform air gap and without DC excitation. It operates both in single and three phase supply. The torque in a hysteresis motor is produced due to the hysteresis and eddy current induced in the rotor by the action of rotating flux on the stator winding. So basically the synchronous motor is a this hysteresis motor is a synchronous motor. That means the rotor is rotating at the synchronous speed and with a uniform gap, but in some case it may be happen that the gap is not uniform. So let us see. So this is the construction of the stator. The stator of the hysteresis motor produces a rotating magnetic field and it is almost similar to the stator of the induction motor. Thus the stator of the motor is connected either to single phase or to the three phase supply. So basically the stator of this hysteresis motor can be of two type. One is the shaded pole type and second one is the permanent capacitor type. So whatever is the case, so in case of saline pole machine, if we give supply, so what will happen? So the poles is divided into two sections. One is a larger section, one is a small section. Over the small section we have a we have a shaded ring, and due to the presence of that ring there is a two fluxes are generated inside the shaded pole, and due to that there is a generation of rotating magnetic field, and that's why the rotor starts rotating. So like that way, in the case of permanent capacitor we also do that. So in case of permanent capacitor also so we actually use this permanent capacitor uh, to split the phase and to make this winding to generate a rotating magnetic field. And we know that when there is a generation of magnetic field, so if we place a rotor inside that, it will start rotating. And if we think of that in this hysteresis motor we are providing three phase supply, then automatically we know that in case of three phase induction motor there is a generation of rotating magnetic field, and that's why it is a self starting machine. That means if we give single phase supply, then the construction may be of shaded pole or permanent capacitor type, and if we think of three phase supply is given to the machine status section, then it is as per the three phase induction motor status construction. Okay, so that means the point is we have to make the status section such a way so that a rotating magnetic field should be generated. Now the construction of the rotor. The rotor of the hysteresis motor consists of the core of aluminium. The figure shows the rotor of the hysteresis motor. The rotor of the motor is a cylindrical one. Yes, it is very important to understand what is there in this particular diagram. So this is the rotor section. So what we have in the rotor section, so as we can see, the outer periphery is presented over here by blue color, and the inner periphery is just there is a lines representing the inner periphery, that not inner periphery, that is the inner section. So the what is the outer periphery? Special magnetic material hysteresis ring. So basically this is a hysteresis ring, maybe made of cobalt and nickel, so those items, and inside that we have non-metallic magnetic material, and the center is shaft obviously. So now the point is, why not the whole material is the special magnetic material? So if we use that, then what will happen? The cost, the weight of the machine is going to be increased, but for the magnetization, for the pole generation and the for the attraction between stator and rotor poles, we need the outer periphery to be special magnetic material only. Okay, but if we if we use that same material inside, so it has high cost, so the overall costing of the machine will increase. It has heavy weight, so the overall weight of the machine will increase. Now instead of that, the inner section of this part, rotor section, if it is made of any non-magnetic lightweight material, then what will happen? The section will be fulfilled, the area will be covered, but the overall costing of the material will be decreased. The overall weight of the overall weight of this machine will be decreased. So those are the reason why a non-magnetic material is used inside periphery of this rotor section of hysteresis motor. Okay, so now how the hysteresis motors are working? When supply is given applied to the stator section, a rotating magnetic field is produced. This magnetic field energizes the rotating rotor ring and induces pole within it. Okay, due to the hysteresis loss in the rotor, the induced rotor flux lags behind the rotor stator flux. The angle delta between the stator and magnetic field Bs, and the rotor magnetic field responsible for the production of the torque. So that means when we are giving the stator supply, maybe single phase, maybe three phase, so what will happen? It is generating some magnetic field. So due to that magnetic field, will be cut by the rotor, and so in the rotor there is the magnetization, and in the rotor magnetization ring the induced pole will be generated. Okay, and due to the and when we are thinking of a magnetic material is used, so that means there will be some hysteresis loss, and due to that hysteresis loss there will be a angle generation between the flux of the stator and the flux of the rotor, and that flux is denoted by the delta. Yes, principle of operation. So to understand the principle of operation of this hysteresis motor, so basically we have to think in the mind of that BH curve. What was BH curve? Already we several times in school level physics, in the college level physics also we have studied what is BH curve. So B is the flux density representing the y-axis, H is the magnetic flux intensity representing the x-axis, and in between that we can draw the BH curve. Okay, so now the if the BH curve is we know that the shape of this BH curve is like a leaf, but if the shape of that BH curve is like that rectangular one, that means it is representing that a huge hysteresis loss is occurring in that particular magnetic material. Okay, so now the how it is working, so let us see that. Okay, so first see that the two diagrams are representing. So first we follow my pointer, so this is one diagram. Okay, so this section is the stator section, this section is the stator section. So what is written? Stator flux in establishes this magnetic field, so there is a generation of magnetic field. Okay, and inside that we have a rotor ring. This is the inside one is the rotor ring. Okay, now when we placed this rotor ring inside the stator section, so it will faces some forces, magnetic field strength, and due to that there will be some rotor pole generation in the rotor section, and those rotor section and the stator magnetic flux are magnetically locked within them, so that at which speed the stator flux is rotating, at that particular speed the rotor is also rotating. Okay, now when it is rotating, see, it is very interesting that the stator pole is acting like this, flux, this is the flux line, straight line is acting like this, and there is a, when the rotor is rotating, there is a angle generation, so that is the flux of this rotor. So follow my pointer, this is the stator flux and this is the rotor flux. So there is angle generation in between them, that is the delta. This is the hysteresis angle generated in between them, and depending upon which the speed of the machine is um, examined. Okay, so the stator magnetic field produces eddy currents in the rotor. The eddy current loss is given by the equation below. So now this is the equation which is representing the mathematical, the repeating the power equation. So Pe is equal to Ke into F2 square into B square, where Ke is a constant, F2 is a eddy current frequency, and B is the flux density. So depending upon these three parameters, we know that we can find out the what is the amount of hysteresis power loss is occurring in the machine. So like this way we can find out the hysteresis torque equation also, which actually depends this torque equation. So in case of this hysteresis motor, the torque is depending upon the flux of the stator section, that is phi s, the flux of the rotor section, that is phi r, and the angle between them, between the phi s and phi r, that is denoted by delta. So that means we can say that the torque of this hysteresis motor depends upon the flux of the stator phi a, phi s, the flux of the rotor phi r, and the angle between these two flux, that is denoted by delta. So that is the torque equation. Here, as we can see in this particular slide, this is the eddy current loss formula. So these are the two formula. Okay, so now the power formula for hysteresis power loss. Okay, so the hysteresis power loss is given by Kh, obviously it will be a constant one, the Fr, that is a frequency one, and B max N, that will be, must be a magnetic flux density one. So let us see what are those. So Fr is the frequency in the rotor. So rotor section we have some frequency. B max is the maximum value of the flux density in the air gap. Okay, so pH is the heat power loss due to the hysteresis. That means when hysteresis loss is occurring, that means the motor is going to be heated, and due to that one, whatever loss is occurring, that is for to find out that loss, we have formula, that is pH, K is equal to KH Fr B max to the power n. So now the constant term, that is the Kh, is the hysteresis constant. Now coming to the advantages of this particular machine. So in the hysteresis motors has several advantages. So and at the same time it has some disadvantages. So first we will discuss the advantages, then we will go for the disadvantages. So as the rotor has no teeth, so there are no mechanical vibration. So it is the most important advantage of this particular machine. So what is happening? So as we can see in this motor, we have a rotor ring, not rotor, the only not that kind of rotor which has a slots in the outer periphery or inner periphery, and over that there is windings. No, not that kind of thing. It has only the high grade magnetic material is used, and due to that, over that there is a generation of magnetic pole. Now the point is, if but there is no mechanical, no teeth are there, so there will be no mechanical vibration. Okay, correct. As the uniform, the air gap is uniform, so the whatever operation is doing or whatever rotation is doing, there will be no noise. So due to the absence of the vibration, the operation is quiet and noiseless. Possibility of multi-speed operation by employing gear train. So that means the point maybe we can think of that where we need this quiet and noiseless operation. So suppose thinking of a recording machine, and the recorder is running by some motors. Now the point is, if the we know that ideally the recorder, some sound recorder should record only the surrounding sound, or someone is singing or someone is playing some instrument, that sound should be recorded or anything nature sound can be recorded. But with that, if the if the noise or the rotational noise of the motor is also generating some sound, then it is also recorded in the with the sound of the other sound. So it is not expected in some cases. So at those cases, this type of machine, using of this type of machine is very useful, because this machines doesn't have any noise. It is quietly, it can operate, and at the same time it can operate at a constant speed. So these are the main advantages of this machine have. So that means two main thing we can say, that it has a noiseless operation, it can run at a constant speed. So these are the main advantages of this machine have. Now the disadvantages and limitation. Yes, definitely, as the high grade magnetic material we are using, it would be a costlier one. Okay, now as we are not using any winding or slots over the rotor, so the flux cutting over the rotor will be less, and the pole generation and the output of the machine is lower. So that means we can, if the output is lower, that means we can say the efficiency of the machine is decreasing. But though also this kind of machine is widely used in all over the world, due to the some advantages. What are the advantages? Already we have discussed: noiseless operation, and we can run at a constant speed. Okay, now availability in very small sizes. Yes, it is one of the most disadvantage of this particular machine. Basically this hysteresis motor are available in the market in a small size. In larger size it cannot be made, because in the terms of cost, because when with the construction size, the cost is changing very exponentially. So that's why it cannot be, large hysteresis motors cannot be made. For the small applications, we can use this type of motors. Okay, now what are the application? Air conditioners, where we need a noiseless operation, because in air conditioners we have the fans, and the fans are those kind of machines. Okay, due to the noise operation, it is using sound recording, as I have told you, sound producing equipments, high quality record players. So all those applications where we doesn't need any sound, any kind of sound, so there we can use this particular type of machine. Okay, so this is all for today. Now I think you are now able to understand what is hysteresis motor, what are the working principle of motor, what are the constructional features it has in terms of stator, in terms of rotor, what are the power equation, torque equation, and what are the advantages, disadvantages, and what is the application of this particular motor has. So this is all for today. Thank you.